We'll start with the meaning of analysis. In chemistry, whenever we get something new substance, we always analyze it. Okay. What there are two types of analysis we do. One is qualitative analysis. Qualitative means what elements are present. Okay. What cation is present, what anion is present, what and all elements are present in that we do by qualitative analysis. Qualitative means simply identification. Second one comes quantitative analysis. This is nothing but your mole concept, where we will identify how much amount of each substance is there, what is the percentage composition. Okay, if it undergoes a reaction, certain kind of reaction, what will be the mass utilized, what will be the volume released. This calculation part, whatever is there, that comes under quantitative analysis. Okay. So but in this particular chapter we are doing only the qualitative analysis in mole concept. Along with stoichiometry we will do quantitative analysis. Okay, before we proceed, couple of definitions we'll see here. You already know this, but still, precipitation, it is a reaction. And what is a precipitate? It is an insoluble solid formed when you mix two solutions. In analytical chemistry we are going to study only about the precipitation reactions mainly. Okay, coming to second part of this, where we will study about amphoteric oxides, their reactions. Okay, so we already know amphoteric oxides or hydroxides are those compounds which react with both acids as well as alkalis to form salt and water. So only these three you have to remember. Remaining metal oxides, they will be basic oxides or they are bases. Only these three will be amphoteric. ठीक है, चलो, हाँ. And now what I am going to discuss, listen to it very carefully. I am trying to make this chapter very easy for you with very simple techniques. Here we use reagents. Reagents are what? They are chemicals only, which we use to test other, what cations are present, what anions are present in the given substance. Okay, so here we use two types of reagents. One is sodium hydroxide solution. You have to write solution because we are using a solution, not the sodium hydroxide substance. Okay, another one is ammonium hydroxide solution. Okay, ammonium hydroxide solution can also be called as aqueous ammonia. Both are same. Means you will take ammonia gas, dissolve it in water, you will get ammonium hydroxide solution. And same way, sodium hydroxide, dissolve in water, you will get sodium hydroxide solution. Okay. What and all cations we are going to detect here? Remember, we are going to detect the cations, not the metals. Cations, calcium ion, okay, zinc ion, then lead ion. Ions when you will get when you take any salt of this particular substance. For example, I will take calcium nitrate. Okay, I will dissolve it in water, means you are taken aqueous. In this, it will completely dissociate because it is ionic compound. So it will form calcium ion and nitrate ion. We are not testing the nitrate ion. In this, we are testing only the cations. Okay, now. So this is what we are getting. So they may give you simply how you differentiate calcium ion and lead ion, or they may give you how you differentiate between calcium nitrate, zinc nitrate, or zinc nitrate, lead nitrate. So mainly you have to understand it is for the cations only. These three. Some people will also have confusion to remember the precipitate color. So make a group of these three. These three will give you white PPT. white precipitate. Colored precipitate, another three are there which will give you colored precipitate. Those are copper plus 2 ion, then ferrous Fe plus 2, then Fe plus 3. These three will give you colored precipitates. So what is this? Simple precipitation reaction, you know. You will take, say for example, calcium nitrate in one test tube. It's a solution you will take. In another test tube, you are taking a reagent, sodium hydroxide solution. Now you will add sodium hydroxide solution to calcium nitrate solution. Initially, drop by drop we will add. Then what we observe, these three, or you taken calcium nitrate, now it will give you a white precipitate. Okay, so here we are making two things. One, when you add initially drop by drop, okay, you will observe some precipitate. Then you will add in excess. What you will add in excess? The reagent. So whenever they ask you observation, you have to write both. Okay, or depends upon the question also. So here when calcium nitrate reacts with sodium hydroxide, initially we will get white precipitate. Same way for zinc with zinc nitrate with sodium hydroxide, you will get white precipitate. Lead also will give you white precipitate. What copper will give us?
Sure.
Yeah.
So zinc and PB, can we just say white PPT or do we mention the exact color?
If you remember for zinc, gelatinous white, for lead, chalky white, you can write. Otherwise, white precipitate is also enough. Okay. So copper will give you pale blue PPT initially when you add drop by drop. Ferrous ion, if it is there, like ferrous sulfate you are using, okay, so it will give you dirty green precipitate. Sometimes they in the question they may change, instead of dirty green, pale green they may write. But remember, green comes to ferrous. But when you are writing the observation yourself, you write dirty green precipitate. Thirdly, for ferric, we will get
Reddish brown.
yes, we will get the reddish brown PPT when you add drop by drop. These all are initial observations. Same thing happens with aqueous ammonia. One exception is there, that is for calcium. So calcium ion will form no precipitate with aqueous ammonia, that is NH4OH solution. Now this itself we can use as a test to distinguish between NaOH and NH4OH. If they ask you how you distinguish between sodium hydroxide and ammonium hydroxide solution, you can simply take any soluble substance of calcium. And I told you soluble substance yesterday, you simply take any metal nitrate, it is soluble in water. So directly take calcium nitrate. When you take calcium nitrate, it will give you white PPT with sodium hydroxide, but it will not give any precipitate with ammonium hydroxide. Okay, so this is one exception here. Remaining all things will work same. Okay, so again zinc and lead will give you white PPT only, and these three will give you same precipitates: pale blue, dirty green, reddish brown, even with aqueous ammonia. Now we will see in excess of the things what happens. So I will write only those which are soluble in excess of NaOH. Remaining, you understand, they are all insoluble. Okay. So initially you have taken zinc nitrate, you added sodium hydroxide, you got gelatinous white PPT. To that gelatinous white PPT, you are adding excess of NaOH. Then that gelatinous white PPT dissolves and forms a colorless solution. Whenever, remember, white precipitate dissolves, okay, it will give you colorless solution. Okay, same thing happens with lead also. It also dissolves. What? White precipitate formed. To that you are adding excess, then that also dissolves and form in excess, colorless solution. Remaining all whatever are there, they remain insoluble. Insoluble. All these three are also insoluble. This is what when you are adding excess of sodium hydroxide solution. Okay. Coming to same thing for ammonium hydroxide solution. Here also only two are soluble in excess, that is zinc is common. So here zinc, white PPT, whatever is there, it is soluble in excess. And you know white PPT when it dissolves, you will get a colorless solution. So one common thing now you understand that zinc is unique because it shows same observation with NaOH as well as with ammonium hydroxide. Initially, you will get a white precipitate, gelatinous white PPT, which dissolves in excess of NaOH or excess of NH4OH. Therefore, zinc you cannot use. Zinc substance you cannot use to distinguish between NaOH and NH4OH because it is giving you same observation. Okay, but remaining, okay, one more is for copper, only colored precipitate which is soluble in excess. Okay, that is when you add excess of NH4OH. Initially you have a pale blue PPT. So pale blue PPT will not give you colorless solution. It will give you colored solution only. So you will get inky blue solution, or you can also write deep blue solution. Okay. So very simple concept is there. Don't get confused. First of all, you should know what is precipitate and all. Based on that only this concept will build up. Many of you write copper will give in excess inky blue solution. First you have to write initially it forms a pale blue PPT which dissolves in excess of NH4OH. Then it gives you inky blue solution. Okay, and only zinc and copper are soluble in excess of ammonium hydroxide. Remaining all are insoluble. Okay, so to just summarize this, what is that? In excess of NaOH solution, make note of these things, only Zn plus 2 and Pb plus 2 PPT soluble. Okay, we're talking in excess. Okay, and in case of in excess of aqueous ammonia solution, only zinc and copper plus 2 precipitates, whatever initial precipitates are there, they will become soluble. All remaining will be insoluble. Okay, so if they ask you what is the observation when you add excess of NaOH to some FeSO4 solution, so what you will write? Initially it forms dirty green precipitate which remains insoluble in excess of NaOH solution. Then your observation is complete, otherwise it is incomplete. Okay, so mainly see in the exam what is your knowledge doesn't matter, how you use that knowledge and how you write, for what question what answer you write and how you write, that matters. Okay, knowledge is important but in the exam how you write, that is important. Okay, so this is the thing. If you understood this, your analytical chemistry first part is already done. Okay, talking about the reactions, very simple, all are double displacement reactions, no need to think much, right? So one example I will give you, they will ask you write the reaction like zinc sulfate when you add NaOH to it. So NaOH, double displacement, all precipitation reactions are double displacement. So exchange the ions sodium and zinc. All precipitates what you are getting, zinc hydroxides. Okay. Yes, Chanvi, you have any doubt?
Yeah, so Mg is what color does it give? White, dull white.
Why Mg we don't have for our syllabus?
Oh, okay,
Okay, only these six. Yeah. So here, so whatever precipitates you are getting here, all are hydroxides and the equations are very simple. So therefore, don't get confused. Simple things keep simple only. And for copper you take copper hydroxide, ferrous you take ferrous hydroxide, ferric you take ferric hydroxide, all hydroxides. Now you know one more thing. If they ask you write the reaction for preparation of ferric hydroxide, you know it is a precipitate. Then you have to use double decomposition or double displacement reaction. Okay, chalo. Okay, here leave the aluminium part. Hmm? Come to lead, zinc, and calcium, and see whatever I have just told you. It is the image of that. Initially, when you take lead with sodium hydroxide solution, you will get a chalky white PPT, which is soluble in excess, and when it dissolves, it will give you colorless solution. Zinc again, white PPT, soluble in excess of NaOH. Calcium, white PPT, it remains insoluble. So only white PPT which is remaining insoluble in NaOH, that is calcium compound. Okay, calcium ion. And here aqueous ammonia for lead remains insoluble, only zinc is soluble in excess, no precipitate with calcium. Okay, now identify the substance. Ruhani, tell me the answer for this.
Yeah, sir, calcium.
Cation that does not form precipitate but form with sodium hydroxide. Very good. And remember children, you write both calcium ion and in bracket Ca plus 2. To get write the answer, you have to write like this. Simply if you write calcium, then it is a metal, it's an atom, not an ion, right? But they have asked here the cation. To make sure you write both. I tell thousand times, but still many of you do mistake in this. Okay, see, these are the colored precipitates as I told you. See how the pale blue PPT looks. This is how it looks. Okay, and it remains insoluble in excess of NaOH, but in excess of NH4OH, this is how it looks. Inky blue solution, deep blue solution, or dark blue solution, inky blue solution. Ferrous and ferric, same observation for both. Dirty green, reddish brown, remains insoluble in excess. Okay, remaining information not needed. Okay, Dhanish, tell me the answer for this.
Uh,
A chloride which forms a precipitate that is soluble in excess of ammonium hydroxide is
copper chloride.
copper chloride,
Sorry, ferric chloride, ferric chloride.
which
Correct, correct.
remains soluble in excess is copper only, no? Hmm? See, I told you just now, in excess of NaOH, which two are soluble? Sorry, this is NH4OH, na? Huh? Which two are soluble? Zinc ion and copper ion. So zinc is not here, so you have to write copper. You have to know this. Then only your work will become easy. Individually, don't try to remember. And for zinc, it is common. In both the cases, it is soluble in excess. But in NH4OH case, it is copper. And another one for NaOH is lead. Lead plus 2 ion. Okay. This one. Aryan, tell me the answer.
Yes, I understand. Sodium hydroxide solution. Uh, Sodium hydroxide, lead.
Lead. Correct. See, you have to be careful here. They have already given hydroxide of this metal. Matlab, you are taking lead, matlab you are already taking the lead hydroxide, which we know it is a precipitate, which is soluble in sodium hydroxide means to this, when you add NaOH, what is happening? It is becoming soluble, right? Because only lead and zinc, they are soluble. Ions I'm talking, they are soluble in excess of NaOH. Okay. Vanishika, tell me the answer for this. The salt solution the salt which in solution gives a pale green precipitate with sodium hydroxide solution, white precipitate with barium chloride.
Sir, iron 2 sulfur.
Iron 2 sulfate. Right. See here, both they have asked. One with a cation by sodium hydroxide, pale green or dirty green if they give you, you know it is ferrous. Second part you have to see, a white precipitate with barium chloride. Always barium chloride is used to test the sulfate ion. Okay. Am I audible? Okay. Always barium chloride is used to test the sulfate. Therefore, if it is giving a white precipitate, it is forming barium sulfate, which is a white PPT. Then it should have the sulfate in it. So therefore, iron 2 sulfate is the answer. Now, write the equation for the reaction. Ammonium chloride is heated with sodium hydroxide. Why I have included this? Because you also need to know what is the test for ammonium ion, because that also comes under the cation. You know, so we do this test. Ammonium chloride will not give you any precipitate, or any ammonium compound will not give you any precipitate with NaOH or even NH4OH. Anyway, NH4OH we don't use because both are ammonium. But we know that when you take any alkali, so here it is NaOH, no? So you heat it, you will get respective salt, water, and ammonia gas. So what we write observation for this? We write the observation for ammonia gas. A basic gas. How do we know basic gas? It turns moist red litmus to blue. Or you bring a glass rod dipped in conch HCl, you will get dense white fumes. Dense white fumes with conch HCl. Okay. So this is the observation we'll write for this. And this is the balanced equation they have asked. So this is NaCl, NH2 and NH3. Okay. Uh, and this is how you will test the ammonium ion. Okay. Ayona, can you tell the answer for this?
Is it ammonium sulfate?
Ammonium sulfate. Yes. Compound P is heated in a test tube, sodium hydroxide solution. Red litmus held changes to blue. Always only one basic gas we know, that is ammonia gas. And if ammonia gas has to be released, then the salt should contain ammonium ion. Right? So that is the observation. Okay. This is a flow chart for your understanding. Whatever we just discussed, it is the same thing. Okay. Uh, to highlight here, the precipitate of ions which are soluble in excess of NaOH, so lead and zinc. Okay, the only cation which does not form precipitate with NaOH, right? So that is ammonium ion. As I just told you, ammonium ion will not give you any precipitate. Okay. Next, uh, state one relevant observation: action of sodium hydroxide solution on ferrous sulfate. Yes, Dhruva, tell me the answer for this. Yes. Hmm. 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 It remains insoluble. Which one remains insoluble? Whatever that dirty green precipitate forms. You know? Okay. We will write initially it forms dirty green precipitate which remains insoluble in excess. Insoluble in excess of NaOH solution. This is how you have to write the complete sentence. Okay. Or you can also say ferrous sulfate with sodium hydroxide initially forms dirty green precipitate. or when you add it drop by drop, it forms dirty green precipitate, which remains insoluble in excess of NaOH. Even though they have not asked what happens in excess and all, but we have to write both. State your observation. Okay. Rishi, tell me the first one. Very good. Yes. So we will get initially white precipitate. It remains insoluble in excess. Okay, both the point we have to write. Fine. Tanisha, can you tell me the second one? What is your observation when you heat calcium hydroxide with ammonium chloride crystals? Are you there?
So can you hear me?
Yeah.
Hello?
Yeah.
Can you hear me?
Yes, yes.
Okay. Calcium hydroxide is heated with
Mm.
ammonium chloride crystals. No reaction.
Mm. You will get
But
ammonia
it
gas.
act with
Hmm.
ammonia, right?
It will give you ammonia gas. That observation you have to write now, whatever previously I told you.
Oh,
Hmm.
okay, fine.
Right?
So,
Hmm.
calcium hydroxide, when heated with ammonium chloride,
Hmm.
forms a basic gas
Hmm.
which turns red litmus blue. What's the red litmus blue?
Correct. Okay. And many of you people write it releases this gas, that gas. You should not write the name of the gas. You have to write the observation for that. Okay. Hydrogen is
Sure,
released means not hydrogen. Yes, Chanvi.
sure. So, can't we just say that no PPT is formed, like no,
No, no, no. That will not work.
what it won't be?
No. When you want to distinguish between two substances, that time you can write in one case it is forming precipitate, in another case it is not forming. That time you can write that. But here you have to write what is the observation. Okay, here you are not forming the precipitate, that is okay. But what is forming? You have some observation for that, no? So that we have to write. Okay, a gas which changes moist red litmus. Okay, these all points you write, huh? Moist red litmus to blue, or you can also write a gas released, this one, and you proceed further if you want that it also gives a dense white fumes with conch seal. Okay, a glass or dipped in conch seal. Chalo. Hmm. Isha, can you answer this question?
Um,
You have a ferric chloride.
is it dirty green?
Hmm. Ferric means plus 2 or plus 3?
Plus three,
Plus 3. Plus 3 के लिए what is there?
reddish brown.
Yes. Okay. So plus 2 will be dirty green, plus 3 will be reddish brown. So plus 2 and this will be plus 3. So simple things, don't get confused. Okay, this is the second case where I have given the flow chart for the ammonia with the salts. Here again, in excess only copper and zinc, they are soluble, their precipitates are soluble. Cation which does not form precipitate with, actually it should be corrected as NaOH, sorry, NH4OH here, NH4OH, that is calcium. Okay, the only metal ion whose precipitate is soluble in excess of NaOH and excess of ammonia, both, that is zinc, that we already know. Okay, next. Who is left? Hershey has done our information. Okay. How will you distinguish between ammonium hydroxide and sodium hydroxide using copper sulfate solution? See, this is a kind of questions I was telling you and how to write the answer for this. This one I will explain you. See, first of all, you have to write neatly. Don't mix everything. Write neatly 2 points. First one, NH4OH solution or ammonium hydroxide solution with copper sulfate solution. Okay. So what we are getting here, initially forms pale blue PPT which dissolves in excess of ammonia solution to form inky blue solution. Inky blue solution. Right? This is the thing for this. Second one, NaOH solution with copper sulfate solution. You should not be lazy in writing the answers during the exam. Then marks will not be there. Huh? Initially forms pale blue PPT which remains insoluble. Make note of this. This is how you have to write the distinguish between questions. Remains insoluble in excess of reagent. Reagent is nothing but NaOH. Okay. This is how you have to write. Even if it is for 1 mark, you have to write completely. You have to write both. Then only you will distinguish between them. They are asking you, you're taking copper sulfate. I'm giving you NaOH and sodium hydroxide, but I don't know which in which beaker it is there. So what you will do initially, will add some amount of copper sulfate, NaOH or whatever reagent is there. Then you add excess. In which case you will get inky blue solution, that is NH4OH solution, right? And in which case it remains insoluble, that is NaOH solution. This is the meaning of distinguish. Okay. So state your observations. When ammonium hydroxide solution is added drop by drop and then in excess to each of the following questions. Dashwana, tell me. Copper sulfate solution with ammonium hydroxide, drop by drop and in excess.
Yes, sir. Pale blue precipitate is formed, and on excess, a deep inky blue solution is formed.
Very good. Okay. Most of the times, copper question is repeated, and zinc question. Copper or zinc, most of the time. Okay. Second one is for zinc. Rohani, tell me.
Yes. So when ammonium hydroxide solution is added drop by drop to zinc sulfate solution, a white gelatinous
Hmm.
PPT is formed,
Hmm.
and in excess,
Hmm.
colorless solution is formed.
Hmm. This precipitate dissolves, right? White
Yeah.
precipitate formed, which dissolves in excess of reagent and forms a colorless solution.
Okay.
Right. I'm writing here only points, but I already told you how to write. Okay. This one. Chanvi, can you tell me the answer for this? Metallic hydroxide, which forms a deep inky blue solution with excess of ammonium hydroxide.
So it's CuOH, what that?
Right.
Copper oxide.
Copper hydroxide, right?
Hydroxide.
Okay. Already they have given you hydroxide matlab. These are all precipitates. Now you are adding excess of ammonium hydroxide to these. Okay. State two relevant observations. Ammonium hydroxide solution is added to copper 2 nitrate solution in small quantities and in excess. Okay. Vanishika, tell me.
So
Ammonium hydroxide and copper 2 ions. We just seen that now. So for this, in excess, what do we add? Like we will add its insoluble and gives wait. Yes, finish. Huh. For initially what it forms? Then what happens in excess?
Soluble 100 zinc.
Hmm. What is your doubt, Aryan? Simple. Initially, or when you add drop by drop, we'll get pale blue PPT. Okay, which dissolves in excess of ammonium hydroxide and forms inky blue solution. Okay, same thing. See, this is also same. Whatever we have seen previous question, that one only. Iona, can you tell me?
Uh, it gives a white PPT when it's added, like it
In
drops and
hmm.
it is insoluble in excess.
Zinc.
Zinc are insoluble in excess and
Ah,
zinc is soluble.
zinc is soluble in both the cases. So what it will form? Colorless solution. Okay,
Yeah.
it dissolves in excess of ammonium hydroxide and forms a colorless solution. Okay. Uh, Important formulas I have given here because sometimes they may also ask you directly formulas or the names of the compounds. Those will be easy questions if they ask you. But for that purpose only I have given here. Zinc hydroxide precipitate, whichever are soluble in excess, what they're actually forming, that colorless solution, what is that? It is respective salt which is soluble in water. So sodium zincate it will form, and lead when it dissolves in excess, whatever lead white split is there, it will form lead sodium plumbite. Okay. Similarly, with excess of ammonium hydroxide solution, these are actually now they are not going to ask you, but I'm not sure in Greenwood High paper sometimes they give you such questions. Okay, so just remember for copper, whatever that D blue solution is there now, what is that? It's a complex compound which is soluble in water. So it forms CuNH4 NH3 4 outside SO4. We call this as complex compound, and the name of this is, see, NH3 is what we call it as amine when we name it. So tetraamine copper 2 sulfate. Okay, if possible work on this, otherwise leave it, no problem. Hmm? Very difficult question paper, if it comes then only this question will come, but just in your head, okay, you have seen it somewhere, right? So this is what it is. Tetramine copper 2 sulfate is that deep blue solution. Okay, now we will see the second part, action of hot and concentrated alkalis on certain metals and their hydroxides. Okay, here let me take a break. Hmm. Now we are taking only caustic soda or caustic potash solution. That is what? NaOH solution and KOH solution. Here. For what? Here we are doing the reaction of hot and concentrated NaOH solution or KOH solution with these three metals. Which are those? Zinc, lead, aluminium. These you have seen last year in hydrogen chapter. If you remember, we have studied this. What is it? The reaction of zinc with hot and concentrated sodium hydroxide. So here these three are special metals because they can give the hydrogen gas with acids as well as bases. So you know we can give hydrogen with acid by displacement, but these three can give you hydrogen with even bases. So here we will get Na2ZnO2 sodium zincate plus hydrogen gas. Okay, balancing. Same way for lead and aluminium. So lead plus NaOH hot and concentrated will give you Na2PbO2 plus H2. Names you remember, sometimes for not knowing the names only you will lose marks. This is sodium zincate. I think in one of the question paper they gave you sodium plumbite, it seems, for you or someone. Okay. Connected to the percentage composition. Okay. Na2PbO2. Huh. Calamine is zinc carbonate. Okay. Calamine will be under metallurgy, ore of the zinc. No, no, no. Zinc carbonate. Okay. And lastly, with aluminum, you will get NaAlO2, sodium aluminate. This we have in metallurgy also. But remember, for sodium aluminate, we have only one NaAlO2. But for zinc, sodium zincate, sodium plumbite, you have Na2Na2. Okay. How to know this? AlO2. These are all anions which contain metals in them. ZnO2 minus 2. This is the anion. We call it as a zincate ion. So sometimes this question is also asked. Name an anion which contains metal in it. So you can write zincate, you can write plumbite also, PbO2 minus 2. This is plumbite. And for aluminate, what will be? AlO2 minus. Not minus 2, it is minus. So it's a aluminate ion. Therefore, you will take only one Na here. But here, to satisfy minus 2, you need to have 2 Na plus. Okay, so this is when these metals react with hot and concentrated NaOH or KOH. If you are treating with K, you will get the potassium. That's it. K2 ZnO2. Okay, K2 PbO2, KAlO2, potassium zincate, potassium plumbite, potassium aluminate. These all things. Okay. Uh, huh. Similarly, the amphoteric nature of these metal oxides of zinc, lead, and aluminium. So when we treat them with the same things, here zinc oxide, lead oxide, and aluminum oxide. These are amphoteric in nature. So we know they will react with bases. They will give you hot and concentrated. They will give you respective salt and water. So what is the salt? Same salt, whatever previously we have seen. Sodium zincate. Instead of hydrogen, you will get water here. See, if you take the metal, you will get the hydrogen gas. But if you take the metal oxide, you will get neutralization reaction, salt and water. And here say I will take KOH, hot and concentrated. Okay, so you will get K2 PbO2 plus H2. And aluminate के लिए say I will take again NaOH. Hot. What you should not forget? Hot and concentrated. Okay, NaAlO2 plus H2. I have not balanced it, but you know how to balance. Okay, so same salts you will get, but along with that water. Hmm? So see the question here. Write the balanced chemical equation for the following reaction. Here, first case, zinc is heated with sodium hydroxide solution. Now, don't go for that precipitation and all. You are not taking zinc nitrate or zinc sulfate. You are taking zinc metal. Okay. So, your reaction should be zinc metal plus NaOH. So, they have given solution, so don't worry. If they mention here hot and concentrated, you mention. Okay. Sometimes in the question they give you. So, then you write it. Now, what is this? Na2ZnO2 plus hydrogen gas. Okay, or they may also ask you what gas is released when zinc is heated with. So heated is given na, so write heating on the arrow. Heated with sodium hydroxide solution. Second one, zinc oxide. So this time it is a zinc oxide plus NaOH. So you will get sodium zincate only plus water because of the amphoteric nature of zinc oxide. Okay, so this is how you have to see. Always when they give you question directly, don't assume in your mind this is what I am going to write. You have to analyze what is given. That will reduce a lot of mistakes what you usually do. Hmm? Okay, Dhanesh, tell me the answer for this.
Um, it is PBCL.
No, it's AGCL. It's actually we didn't learn here, but this is the characteristic test for AGCL or CL ion. See, how do we identify the chloride ion? We take the silver nitrate solution, precipitation reaction only. Any compound of Cl, like NaCl you take, HCl you take, okay, anything which is containing chloride ion, that will give you this test. So what you will get here, AgCl, which is white PPT, and lots of white PPTs are there. How do we distinguish between them? So what we do, we add some other reagent like excess of NH4OH for this, which is soluble, and when it is soluble, always white precipitates will give you colorless solution. Okay, this you remember because this is required to write the distinguish between kind of questions. Okay, so this is a characteristic test for chloride ion. PbCl2, again that also I will explain here. PbCl2, okay, let me take a different slide for that. PbCl2 and PbSO4, yesterday we have seen both of them are precipitates. This is white PPT, this is also white PPT. Now, how do we distinguish between them? We heat them or we add hot water. So, white PPT dissolves on heating, or you can say in hot water. Whereas lead sulfate white precipitate, it remains insoluble in hot water or on heating. Okay. This is how we have to distinguish between lead chloride and lead sulfate precipitate. But what kind of question has been asked, that we'll see. Okay, here identify the cations, and again I am telling you, you write both the name as well as the symbol for the cations. Yes, Dhruva. Ha, insoluble in hot water. Okay. Identify the cations in each of the following cases. NaOH solution added to the solution A gives reddish brown precipitate. Okay, Isha, can you tell me what will be the cation?
Um,
Reddish brown precipitate.
Fe2 plus.
Same mistake you're doing, huh? Fe plus 3.
Uh,
Ferric.
I can between those two.
Very simple. Remember anyone.
Yeah.
Okay. So ferric is there. Sorry, reddish brown. Okay, I will tell you simple way to remember it. Reddish brown is a rust. Rust we know, right? It's
Yeah.
reddish brown in color, right? So what is the composition of rust? It is ferric oxide, Fe2O3. So ferric oxide matlab it has Fe plus 3 in it. Okay, so this is how you can remember. Fe plus 3 is like rust, so reddish brown, and Fe plus 2 will be dirty green. Okay, here you have to write both, as I told you, iron 3 ion, or even if you write ferric ion, that is also correct, but also write the symbol. Okay, second one. Tanisha, tell me, NH4OH solution added to solution B gives white PPT which does not dissolve in excess.
Calcium.
Which one? Calcium?
Yeah, we
Okay.
talked about
Calcium will not give
because
precipitate only, huh?
no, it does. With NaOH, it does.
But it
It
is
gives the
NH,
white PPT.
it is NH4OH, na here.
Yeah, but doesn't that actually give a PPT with NH? Oh, NH4. Sorry, sorry.
Hmm.
Um, Magnesium.
Magnesium, why it is coming here? Did they teach you people magnesium also in school?
I remember doing magnesium
Oh,
and being insoluble in the
okay,
NH4.
okay. But it is not part of our syllabus. Okay.
It's lead. No.
Hmm.
Huh?
It is lead.
Oh, sorry.
See, zinc is anyway white precipitate soluble in excess. Calcium will not give any precipitate, but lead will give you white PPT and insoluble in excess of NH4OH. Okay, so we have to write lead in bracket 2 ion. Whichever has variable valency, we have to write its valency in bracket. Third one, this is I think we gave you in the test B and C. Anyway, solution. Tell me, Dhanish, what is the answer for the C part?
Yes, sir. So is it mg to plus?
I'm telling you, people, MG is not part of our syllabus. Why you are telling that?
Sir, I never studied it.
Okay, leave MG. Any other thing you tell me?
Calcium.
Calcium ion. Okay. What is there in the syllabus that you write? Okay. MG, if it is given, maybe extra information they might have given in your book. Otherwise, if your teacher told that you have to learn that also, then okay. Huh? Otherwise, I think it is not there. Sure. What would you observe in the following case? Same thing, right? Copper sulfate. Let's see. Again, anybody will do mistake or what? Rishi, tell me.
Yes, sir, yes, sir. When ammonium hydroxide is added to rock sulfate, it gives a pale blue precipitate,
Hmm.
which in excess it becomes an blue solution. Blue solution.
In excess, it dissolves, correct? And
In excess, it
forms
dissolves and it's an inky blue solution.
inky blue solution. See, when precipitate dissolves, it becomes a solution. It no longer a precipitate. Okay. Precipitate means it is not soluble. Precipitate meaning is what? Insoluble solid, right?
Yes, sir, yes.
Hmm. Okay. Again, see what previous year questions, one year seeing, what kind of questions they have asked. Mainly observations. Then identify the cations. And some 1 or 2 marks here and there we are observing, write the equations. Okay. So this chapter is very easy to score if you don't have any confusion. If you're having confusion, then you have to revise it again and again. Okay. How many times you revise it properly, that much easy it becomes. I am teaching here, no, lots of times now. Now I remember everything. Otherwise, if I don't teach for some 2 3 months, then I again have to revise. Right? So that is the power of revision. Okay. Excess of ammonium hydroxide to lead. Darshwana, tell me.
Sir, white precipitate is formed.
Hmm. This is initially in excess.
Yeah. Colorless solution.
In excess of ammonium hydroxide, only two are soluble. One is zinc, another one is copper. So for lead, you have to write remains insoluble. Okay.
So if they ask, so in the question they only asked X's. So if you write both initially and in X's.
Yes. Because initially without writing that there is a white PPT formed, how can you write it is soluble? Hmm? Okay. See, whatever they give you, you always write both. Initially what happens? In excess what happens? Sodium hydroxide solution is added to ferric chloride. Okay. Aryan, tell me.
So initially rendition of PPT
Hmm.
and in X's it's insoluble.
Okay. Insoluble in excess. So therefore I'm telling you, if you know which is soluble in excess, remaining all will be insoluble. No need to remember them. Hmm? Okay. Again here identify the cation. The same question what we just discussed, it is repeated here. Okay, let's see. Chanvi, tell me. A. Ammonium hydroxide. Solution B. White PPT does not dissolve in excess.
Does not dissolve. Sir, it's lead.
Yes. Lead to,
Ion. Oh,
yes, lead to ion in bracket Pb plus 2. Okay. Iona, tell me the B part. Sodium hydroxide solution T C white PPT insoluble in excess.
solution.
Hmm?
I'm not very sure.
We just discussed it, the same question we discussed. See,
But that
NaO solution added to solution C gives white PPT which is insoluble in
oh,
excess. Calcium ion, right? White precipitate.
oh
Which
yeah,
are the
that
white precipitates? How to analyze, White precipitates are calcium, zinc, lead. And which
that
of them are soluble in excess? Zinc and lead. What is left? Calcium. Okay, this is how you do. Calcium ion,
that
Ca plus 2. Distinguish between, okay, these are the questions will come 2 to 3 marks. Usually it is repeating. Okay, see, one example I already told you. This case, they have not given any reagent, but you have to use a reagent. Many of you directly write. Huh? Don't do that. First, what you do, write what reagent you are using, right? So, reagent, how you select the reagent? That here, see, calcium nitrate, zinc nitrate, anion is same. Okay, then you have to distinguish between calcium ion and zinc ion. Now, then okay, we have to come either sodium hydroxide solution I have to take because cations, no, or ammonium hydroxide solution. So you can take ammonium hydroxide, that will become very easy, but you can also take sodium hydroxide, not a problem, but you should know what is it. So when you take ammonium hydroxide and I will take calcium nitrate, so what you will write? Calcium nitrate with ammonium hydroxide solution, no precipitate. Okay, and zinc nitrate with ammonium hydroxide solution forms white PPT. That's it. No need to again. Now in this case, don't write excess what happens and all, because now initially only you will come to know. In one case white PPT is forming, in another case it is not forming, right? So no caution about writing in excess. But imagine instead of this you have taken NaOH, then you have to write in excess what happens, because initially calcium nitrate with NaOH, it will form white PPT and remains insoluble in excess. I am just writing the words here, but what I am telling you, the sentences that you have to write. Okay, na? And same thing for zinc nitrate. Zinc nitrate, initially what it forms? White PPT. Then this time why you have to write in excess? Because both are forming white PPT initially. Hai na? Therefore, you have to write in excess, it is soluble and forms a colorless solution. Second case, see, ammonium sulfate, sodium sulfate. Again, sulfate is common. So cation differentiate you have to do. Now I told you first only. If you want to differentiate between ammonium ion and sodium ion, okay, you can take any calcium compound which is soluble in water. So I will take here calcium nitrate solution. You have to take the solution. Whenever you are writing the precipitate, you have to take the solution. Okay. So what happens here? Ammonium sulfate with calcium nitrate solution. Okay. NH4 twice SO4 solution. Okay. No precipitate. Sorry, 1 second. Here you can't use this. Sorry. Why? Because this is not NH4OH and NaOH. This is sulfate and sulfate. So what we will take here? Tell me. With ammonium sulfate and sodium sulfate, what we can take? Barium chloride, if you take again, it is for anion is same now. Both the cases you will get barium sulfate. Same mistake we are doing. See here, crystals they have given now, correct? So what I will do, I will take sodium hydroxide solution. Okay, what happens here? No precipitate. In both the cases, you will not get any precipitate, but you are taking ammonium sulfate crystals, and to that you are adding NaOH. Then you, what you do, you heat it, and what we will get here? Ammonia gas. Correct? We will write in this case a basic gas is released which turns moist red litmus blue. Whereas if you take Na2SO4, sodium sulfate plus NaOH, here you will simply write no gas released. Okay? Because sodium sulfate with NaOH will not give you any gas. But ammonium compounds will give us ammonia gas with alkali. Therefore, we have to select an alkali here. You can take NaOH, KOH, or even calcium hydroxide solution is. Okay, na? Third case you see magnesium chloride, magnesium nitrate. Here cation is same. When cation is same, don't take NaOH or NH4OH. You have to use either silver nitrate or lead nitrate. Okay, na? Silver nitrate or lead nitrate. Why? Because magnesium chloride. Say I will take silver nitrate solution, AgNO3 solution with magnesium chloride and silver nitrate. We will get AgCl, that is a white PPT. But same silver nitrate with magnesium nitrate. See, nitrate and nitrate. Can you expect any precipitate here? No, because whenever they exchange, again you will get silver nitrate, magnesium nitrate only. No? So here we will not get any precipitate. Same thing you can use instead of silver nitrate, you can also use lead nitrate solution. Same observation. For MgCl2, you will get a white PPT. What is that white PPT? Lead chloride. But don't write lead chloride is formed. You have to just write white precipitate is formed, and lead nitrate with magnesium nitrate, no precipitate is formed. Okay. You can also put column left side, right side, you can write, or just write the sentences, but write them clearly. Okay. Again, answer the following questions. How you will distinguish between ammonium hydroxide, sodium hydroxide using copper sulfate. This time they have given you already. Okay. So I think we have discussed this in the first case itself, right? So with ammonium hydroxide, you will get pale blue PPT, in excess inky blue solution. With NaOH, pale blue PPT, insoluble in excess of NaOH. Okay. This question I gave you during the exam and also explained it here. Raise your hand who knows the answer for this. For second part. Even if it is wrong, okay. At least try. What is the answer for second one?
Sure.
Yes. Yes, yes.
So sentence.
Sentences.
Can I just say it?
Hmm.
So when dilute hydrochloric acid is added to lead nitrate, it gives PbCl2, uh, which is soluble in hot water, and
Not
then PbSO4 is formed.
PbCl2. You have to tell what is the precipitate. Color. Don't tell
So
the
white
compound.
just white, right?
Hmm.
White precipitate.
Hmm.
So do we also have to mention if it's soluble and insoluble?
Yes, because in both the cases you'll get white PPT, no?
Okay.
Hmm.
It gives white precipitate and is soluble in hot water.
Hmm.
And
Hmm.
lead nitrate, white precipitate, which is not soluble.
Right. I just explained it previously between lead chloride and lead sulfate, but here it is little different. You are getting it as a product. So what you're doing here, dilute HCl, you're taking lead nitrate. Okay. So here what you will get? Lead chloride, which is a white PPT. Don't write the equations. I am writing it for your understanding. Hmm. White precipitate, soluble on heating. Okay. Same thing for dilute sulfuric acid. Dilute sulfuric acid, when you add it to lead nitrate, you will get a white precipitate of lead sulfate, which is insoluble in or on heating. Okay. So this is how you will solve such kind of questions. Same thing, chemical test, lead nitrate, zinc nitrate. So you can use NH4OH. You have to use only NH4OH here because lead and zinc with NaOH will give you same observation. Both form white PPT soluble in excess, but only with NH4OH solution, right? Zinc white PPT dissolves in excess, lead white PPT insoluble in excess. Sodium chloride, sodium nitrate. So now we have to distinguish between chloride and nitrate. Same thing as I told you, silver nitrate you use. Silver nitrate solution. So with sodium chloride you will get white PPT, that is AgCl, and with sodium nitrate no PPT. See, they may change, but whenever you have to distinguish between chloride and nitrate, you use silver nitrate or lead nitrate. Okay, but you want to distinguish between the cations, either you have to use NaOH or NH4OH solution. Practical chemistry question may, like what is the salt you have to identify, or the cation, anion, these kind of questions, or test for particular gas, observation for particular gas, right? These kind of questions only will come. Chalo. Too much talking from my side. Vanishika, can you read the first question? Yes, read the first question.
So, on performing a flame test, salt B produces a lilac colored film.
Hmm.
The solution is a white precipitate
Hmm.
with another solution which is soluble in ammonium.
Okay. Do you remember the flame test's color for lilac colored means which metal? They were
Potassium.
right. So remember these four: sodium, potassium, calcium, and copper. Sodium is golden yellow. What is this? Flame test. Flame test means when you hold them on the flame, it will impart some color to the flame. So that is the one. Lilac, calcium, brick red, because they can change anything. Na? Copper, bluish green. This is not the color of the element. This is the flame color. Yeah. Okay. Vanishika, this should be potassium. Okay, na? Second part is giving you the hint about the anion. White precipitate with the silver nitrate. Which anion could be the white precipitate and soluble in ammonium hydroxide solution? We have just seen the previously.
The zinc.
Hmm? No, no, no. Anion you have to identify. Silver nitrate is there. Okay, you are getting a white PPT. What you will add anion? Chloride. Chloride, because white PPT of silver is AgCl, which is soluble in excess of ammonium hydroxide. Okay, now. So this is Cl. This is how you have to identify. You have to, by practice, you have to remember what is white PPT formed when silver nitrate. It should be AgCl. That white PPT is AgCl. Matlab that anion should be chloride ion. So what they have asked here, you have to identify the salt here. So we have to write potassium chloride. Do not write the formula. If you want to write in the bracket also, no problem. But write the name as well. Do not lose marks for not writing names. Okay. Second one, Dhanish, can you read?
Yes, sir. When dihydrogen is added to salt cube,
Hmm.
the brisk effervescence is reduced and the gas does lime water milky.
Hmm. Next part.
Uh, when an H4OH solution is added to the formation,
Hmm.
after adding dilute HCl,
Hmm.
it produces a white crystal which is soluble in HCl and H4OH solution.
Hmm.
Uh,
So there is
so,
acid and you have some salt, and you are getting the gas which turns lime water milky.
so salt,
Hmm.
so it's a white crystal which is soluble in HCl and H4 solution is zinc. So it's
Uh.
the correct answer for.
Hmm. Hmm.
So,
So you know zinc is there.
yeah, zinc is there.
Okay. And which one will give you which gas turns lime water milky?
Carbon dioxide.
Okay. Then what should be the anion?
CO2.
Anion. CO2 is a compound, not an ion, no?
Yeah, it will be CO.
Okay. Which substance will give you CO2 gas when it reacts with acid? Hmm?
A carbonate.
Carbonate. So that is the one, no? Then.
So that is CO2.
Huh. See, remember children, if you are getting a
You asked
CO2
me
gas,
anion.
huh, CO2 gas will come from the carbonate. Okay. This part you have to know by now. SO2 gas, if it has to come, you should have the sulfide. When metal sulfide and bisulfide react with acid, you will get SO2 gas, correct? Then you want to get ammonium ion, then you should have the ammonium ion in the compound. Ammonium salt should be there. Okay, these are the things. Do not write carbon dioxide gas here because they are ask you salt you have to identify, na? So your salt is zinc carbonate. Zinc carbonate. See, if I write zinc bicarbonate, that is also not wrong. If I write zinc sulfite, because SO2 gas also turns lime water milky, correct? So that can also be accepted here, even bisulfite. Okay, but zinc carbonate is fine. Okay, Chanvi, can you read first one?
Yeah, sir. Salt P has a light bluish green color. On heating, it produces a black colored residue. Salt P produces a brisk effervescence with dilute HCl and the gas evolved turns lime water milky, but has no action with acidified potassium dichromate solution.
Very good. So can you identify the metal? Bluish
No,
green.
yeah,
Hmm.
bluish green is,
Hmm.
I think, copper, no?
Very good. And another confirmation is that it forms a black
Black,
colored residue
copper
on
oxide.
heating.
Yeah.
Yes. Okay, so
And then
this should be copper, huh?
turns lime water milky, but not. Oh, it's CO2.
Hmm.
So that'd be carbonate ion.
Correct. Now you have to write the compound. What is the compound? Salt you have to
Copper.
identify, no?
Uh, oh, copper carbonate.
Copper 2
One.
carbonate.
Oh, so we have
Okay.
to write it like that.
No, copper 2 carbonate only we have to write for Greenwood High.
Oh. So
Huh. If you write copper carbonate, you did all of this, you write copper carbonate, you will lose marks. Okay.
okay.
Chalo. Next question. Isha, can you read?
So same thing, sir. Copper, copper. Sir, that's what, sir.
Copper?
Copper 2 and copper, let them take plus heating. It's same,
You
sir.
can't go and tell them, na. They are not same actually. Copper 1 carbonate is also there, na. Whenever there is a variable valency, you have to write that.
So, but you said that whenever you write reactions like lead carbonate, we just assume lead as 2, right? So why
Correct.
can't we assume
Correct.
copper carbonate is 2 here?
Correct. When they give you lead carbonate, you take it PbCO3. But when you have to write, when you have to write, you have to write lead to carbonate only. Okay,
So
that's
there's
what I told
different
you.
rules for them and different rules for us.
Yes, that's how it is there.
Okay, sir.
Okay. Array, what is there? You just write a whenever variable balance is there. Just write the variable balance. You already know. But I understand your feeling. But see, if they are not giving you marks, then you make sure you will get the mark by writing what they want. That's the only option. Because we can't go and tell, they also can't go and tell to the board people. Correct? Therefore, okay. Isha, can you read the next one?
Salt cue is white in color. On strong heating, it produces soft yellow residue and liberates reddish brown gas.
Hmm.
Solution of salt cue produces chalky white insoluble precipitate with excess of ammonium hydroxide.
Okay. Can you identify the cation and anion? See,
Um,
it is white in color. White, whenever it is there, remember it is not copper. Okay? ठीक है. It on heating, it produces a buff yellow residue, liberates reddish brown gas. Do you know what is the reddish brown gas?
yeah,
Which is
nitrogen gas.
NO2, nitrogen dioxide. है ना? हाँ.
And that buff yellow, that's zinc.
Zinc, remember, zinc, if it is there, zinc oxide is there, it is yellow only. That too, when hot. They have to mention that. Okay. And it is white when cold. If they mention both of these points, then you have to assume it is zinc. Otherwise, don't. Okay. What is this buffalo other one? Lead
Oh,
oxide. Correct. Okay. Now you know lead oxide is there, NO2 is there. Then what is the salt Q?
PbNO3.
Hmm. Straight away we can write lead nitrate from this only. Remaining part will confirm that. See, solution Q produces chalky white insoluble in excess. So that white insoluble in excess is lead only. So you have to write here what? Again, lead 2 nitrate. Do not write the formula lead 2 nitrate. If you want, you write in the bracket. Again, don't do mistake in writing the formula. Then also they will cut. Okay, lead 2 nitrate will be the answer. ठीक है. Rishi, read the next one.
Yes. Salt R is black in color on reacting with concentrated HCl. It liberates a pungent greenish yellow gas which turns moist starch highlighted with blue black.
Hmm. You have to identify the salt. Okay, na? Do you know what is the greenish yellow gas? Greenish yellow gas. It is chlorine.
Glory, okay, okay.
Okay, star cider paper turns blue black. Okay, na? So basically, salt are don't many people what they do black in color. Matlab they straight away take copper oxide. That is not correct. Hmm? So here salt are is some oxidizing agent. When it reacts with HCl, it will give you chlorine gas. So that will be manganese dioxide,
Manganese dioxide.
MnO2.
Yes,
Okay.
yes. So,
So,
sir,
huh.
so then how do we know if it's like copper or
Copper oxide, if it is there, na, copper oxide is a base. Okay, na. So what you will get when acid plus base react, you will get salt and water, na. You will
yeah,
not get any gas.
oh, oh, okay, okay.
Got it?
Fair.
Hmm.
Yeah, yeah.
And they may also ask you how you distinguish between MnO2 and CuO using HCl. So again, you have to write same thing. MnO2 with HCl will give you greenish yellow gas, whereas copper oxide with HCl, no gas is released because it is simply neutralization. Okay.
So, but how is MnO2 salt? Because
MnO2 is a salt because it is an oxidizing agent, not a base.
aren't we supposed to write MnCl2?
Why?
Because
MnCl2 is a
of,
compound formed,
yeah,
but here you are taken a salt R and you are treating it with HCl. So it is a reactant, not the product.
okay.
MnCl2 is what you are getting after the reaction. MnCl2 plus H2O plus Cl2. है ना?
Yeah, yeah.
Hmm.
Okay.
See, usually metal oxides should be basic oxides or amphoteric. But MnO2 is not basic, not amphoteric. It is especially an oxidizing agent. Okay, sometimes they also do mistake. Salt, it may not be salt, but it can be considered salt sometimes. Okay. Take the next one. Following observation, name the anion. See, name. They have written name the anion. So write the name only. Okay. Chalo. Ruhani, can you read?
Yeah, so when a crystalline solid P is warmed with concentrated H2SO4 and copper turnings, a reddish brown gas is released.
Hmm. So reddish brown gas is what?
Nitrogen dioxide.
So if it has to form, what should be the anion?
Nitrate.
Yes. Okay. Whenever remember, if NO2 has to form, what should be the anion? It should be the nitrate. Nitrate ion. Remember, nitrate is NO3 minus, nitrite is NO2 minus. Okay. Do not make a mistake here. Nitrate, ATE. And here don't identify the salt because they have asked you identify the only the anions. Okay. Chalo. Next one. Dhruva, read the next one.
When few drops of dilute sulfuric acid is added to salt R
Hmm.
and heated, a colorless gas is released, which turns moist
Hmm.
lead acetate into silvery black.
Hmm.
This is sulfide, right?
Sulfide. Very good.
Sulfide ion.
How do you know sulfide it is?
So the moist lead acetate will
Silvery
turn
black.
silvery black.
Yes. Sulfide ion. Because this the gas released will be H2S gas, which will turn this. So again I will write here. If H2S gas is there, then the anion should be S minus 2. Okay. Next. Dhanish.
Yes, sir. With few drops of medium nitrogen solution in a salt cube, a white crystal is formed, which is soluble in HCl.
Hmm.
Um,
Barium nitrate or barium chloride, which are, what precipitate? White precipitate formed with barium is what?
white precipitate formed with barium. It's carbonate, right?
That is there, but second part also you have to see. Carbonates will react with HCl, no?
Sulfide, sulfide.
What?
Sulfide, right? It forms a white precipitate.
Sulfite?
Yeah.
You're talking about SO3.
Yeah.
Okay. Hmm. Yes, Tanisha, tell me what is your answer?
It will be sulfate ion.
Sulfate. Right. Hmm. See, I will tell the difference here itself. Sulfate and sulfite with barium. Say barium nitrate, you take barium chloride, you will get barium sulfite, barium sulfate. The thing is in the second part. Both of them will form white PPT. Even sulfite also gives you white PPT. But when you treat it with HCl or any other mineral acids like H2SO4 or HNO3, what we know, metal sulfides will react with acids, correct? They will give you salt, water, and SO2 gas. Matlab they do not remain insoluble. They dissolve. Dissolve matlab they react. Okay. So they are soluble in mineral acids. But sulfate, when it is there, it remains insoluble in mineral acids. Okay, second part you have to observe. So the answer should be sulfate, not the carbonate, not the sulfite. Okay, and simply always remember whenever barium is there, okay, white precipitate is most of the time it is sulfate only, and specifically if they mention insoluble in HCl, it is 100% sulfate. Okay. um, Ayona, can you read this?
Yes. These are the two crystalline salts expected when heating is fused by anhydrous powder. P is dissolved in water that is added to one part of the solution. In another part, specifically barium chloride is added. The compound P is copper sulfate.
P is copper sulfate. Are sure?
Yeah, when copper sulfate is heated, then it becomes white anhydrous.
Okay, what is that white anhydrous powder? Blue crystalline salt. Huh? Blue crystalline. And it becomes amorphous.
CuSO4.5H2O.
Okay, what is the name?
Uh, Hydrated copper sulfate. Yeah.
Okay. Common name is blue vitriol, if you remember, right?
Oh, yeah.
Ha. And you can also write copper sulfate pentahydrate. To be specific, 5 means penta, so pentahydrate. This one we know na. So when you take copper sulfate pentahydrate and exposed to atmosphere, or you heat, or you add Kong sulfuric acid, also dehydrating agent, you will get copper sulfate plus 5H2O. So this copper sulfate is amorphous. Amorphous meaning it is not shiny. Okay, crystalline means just like sugar crystals, it has a definite shape and it is shiny. But when you heat it, it loses that water of crystallization and becomes amorphous, just like the powder. Okay. Huh. Okay, Ayona, can you tell me, mention one observation when zinc is added to solution P? Solution P will be copper sulfate solution now because you are adding water. Hmm?
Yeah, will get reduced, right? To ZnSO4 plus Cu.
It will get reduced, but you have to write the observation. It's actually displacement reaction.
Uh, yeah, so as that happens, you get copper metal, so a reddish brown metal as well.
Okay, what
Will
happens
be
to color
present.
of the solution? Color of the solution?
It will no longer remain blue and turn colorless.
Huh. So you can write both observation. Uh, Blue solution turns colorless or changes blue to colorless. Okay, or and another point, pink metal or a reddish brown metal formed or deposited on zinc.
I didn't, sir,
Hmm.
I didn't get this observation. How do you get it?
Okay, very simple. See what they did. P dissolved in water. P is what? Copper sulfate pentahydrate. When you dissolve it in
Yeah,
water, what you will get? Copper sulfate solution only, na?
yeah,
Because water will become water only, right? Copper
yeah.
sulfate solution may, what you are adding, zinc is added to one part of the solution, means you have made it into two parts. Imagine two parts. This is one, this is
Okay,
another. In one test tube you added zinc metal. So copper
okay.
sulfate plus zinc is what? Displacement. Zinc sulfate
ZnSO4.
plus copper, है ना? State the color of the precipitate formed when barium chloride is added to the solution P. That is in the second part. You are adding
Okay.
barium chloride. So again, sulfate is there, है ना? So what will get? White precipitate. Hmm? Everything
Okay,
revolves
fine.
around these things only. So if you make sure you are getting it right, then your answers also will be correct. This is the last question.
So, but then for the table that
Hmm.
so for the B part,
Hmm.
how do you get that? Blue solution turns colorless.
Copper sulfate is blue, na? Zinc sulfate is
Okay.
colorless. Zinc zinc compounds are colorless,
Oh,
okay, or white.
okay,
But when you dissolve in water, it becomes colorless. And copper metal is formed here, so reddish brown metal deposited.
okay, fine.
Hmm? Okay. Last question. Distinguish between the following pairs using the reagent. Already reagent is given. This one I just explained previously. Okay. Who will tell me the answer for this? Raise your hand. Magnesium oxide and copper dioxide using conch HCl. Anybody?
So can I answer the next one?
Next part. Okay, but this part. Yes, Vanishika.
Yes, and manganese dioxide, we have to concentrate HCl to produce greenish.
Very good.
And copper 2 oxide doesn't produce.
Yes, no gas released. Okay. Just now we have seen previously. The magnesium oxide is an oxidizing agent. Okay. For your, sometimes they may also ask you to write the reagent, sorry, equation. And this is the, remember, this is the only reaction of conch HCl you have. Okay, so you will get MnCl2 plus H2O plus Cl2. So you are getting a greenish yellow gas. Yes. Second one, Tanisha, tell me. They're not audible. Huh. Huh,
Can
yes.
you hear me now?
Yes, yes.
So ferrous sulfate, it forms a really clean PPT.
Hmm.
Oh, yeah, and then ferric sulfate forms a reddish blue PPT.
Reddish?
Brown sulfate.
Huh, right. Okay, that's it. Reddish brown PPT for ferric and this one. Third one, Danish, would you like to try the third one?
Not sure.
Hmm? Array, we just discussed it now previously.
So I only told the sons.
Hmm. Danish,
So
Danish.
so where it this
Ar,
got
okay, you're C. Okay, anybody else?
so was it the hot water that
Anybody else? Raise your hand. Let's see.
so it's the same thing which I said.
Raise your hand, please.
Oh yeah, no, I understood.
Tanisha.
Okay, so dilute HCl
Hmm.
forms a biprecipitate precipitate of lead chloride, which is soluble in hot water,
Hmm.
and then dilute H2SO4 forms a white PPT of lead sulfate, which is insoluble in hot water.
Very good. But don't mention lead chloride in lead sulfate. Hmm. Just write white PPT. Okay. Soluble in hot water on or on heating. Soluble on.
Oh, okay. This answer I got.
Huh. This and this one is white PPT insoluble on heating. See, if you know what is going to form, based on that we can explain. Hmm? Okay.